Back again. Here today to talk to you guys about an HP-75 software development prototype that I happen to have in my collection. This is the top view of the prototype. It's an OS development prototype. That's the OSDP on the top. You can see the access to 4 EEPROM sockets. That's enough to do one HP-75 module development. This is the front view of the system. We'll zoom in on the label. This label would indicate that there were at least 43 of these floating around in June of 1982 at a value of $500. Okay.
Does that mean it was taken over a border?
Yes. These were set up. You'll see that they're really rugged units, a lot more rugged than even the production product. And they were distributed to software developers for the plug-in ROM modules. Thank you. A lot better. Okay, the HP-75 plug-in modules, those of you that are familiar with the HP-75, look sort of like this, except this is a clear version. It has, for any of you that have taken them apart, they have these little cantilever springs. The whole module was designed, and the springs were designed for a maximum number of insertions. They're also, if you've tried to plug or unplug the modules out of the 75, and you're thinking, well, it's tight because it's old. No, it's tight because it was tight from the beginning. And when we were developing the pod and whatnot, we developed a little aluminum removal tool, which was just a piece of aluminum with a curve on the end so that you could yank the things out. Otherwise, you break your fingernails a lot. So this development unit basically uses a standard module with standard springs, except it's got a longer PC board to connect up the cable to go down to the unit below. It uses a standard HP-75 AC adapter. You guys, I'm sure, have probably dozens each. The unit on top looks like a stock HP-75, but it's not, and I'll show you why later. Back view of the unit, there's little pieces of silver here and there on the unit. Those are actually ESD test points. One of the things you do is you zap the unit while it's running to see if the code gets lost and that kind of stuff. This is a bottom view of the unit. For those of you familiar with the HP-75, you'll see that it has an expanded memory module, a whopping 8K, and it does not have a battery. Gets power through the base unit. Top view after the 75 is removed. As I mentioned, this is a fairly heavy sheet metal. This thing's built like a tank. Large view. The unit's built with 5 stacked standoffs. I'll show you a little bit more. Here, there's one in each of the 4 corners and one in the middle of the board. It's stacked because there's a little standoff to raise the PC board up off the bottom of the case, and then the top standoff connects to the top case to set it up so that you could stand on it if you wanted. Okay, the unit unfolded. The power comes in the back, but the analog electronics, the power supply stuff is in the front. So there's a cable that runs from front to back. The cable's long enough so that you can open up the unit flat like you see there. But you can also disconnect it. It's got a disconnect so that you can separate the top from the bottom. Okay, this is the bottom case. It's an exposed view. I've got a lot of photos in here. The goal of this presentation is to archive this so that you could almost build one yourself. Okay, enlarged view. Zooming in on the back of the PC board, you see the 0 insertion sockets for the plug-in ROMs. you also see some other EEPROMs there. Those are the system ROMs for the 75. The 75 that you saw on the top, the reason it's not a real 75 is all the ROMs are down here. So what you could do is you could put basically different revs of the OS in the unit and then close it up and use it to develop the programming modules. So the 75 doesn't, in the unit does not have ROMs inside. The front view, how many people are familiar with the 75 system architecture? One. Okay, we're a dying breed. The 75 is like the 85 in that the memory is accessed through something called a memory address register. So it's some addressing logic, it's a multiplex bus. And so this is the logic that implements that address register and the addressing logic for the part. I zoomed in so that you can see the part numbers. You notice that the part numbers, if you're familiar with, if you've taken apart HP systems, HP was a big enough consumer that they had people mark special HP part numbers on their integrated circuits. And they were the classic 1820- something or other. Zoomed out version. The front. Okay, so this is a components list of everything that's in the unit with the 1820 numbers. And when I show you the PC board, I'll point out that every integrated circuit's got a label on the PC board for what it is. Now, again, if you're not familiar, there's actually a bench brief, and it's referenced down in the corner, that lists the cross-reference of the 1820 HP numbers to standard industry part numbers. I'd point out that every integrated circuit in this system is a standard part off the shelf. So from an IC perspective, you could build one of these.
Are they all still available?
Yeah, they are. I actually looked. These are standard 74 LS type parts. So yes, this is a copy of the bench briefs. When I went looking for the part numbers, came across this bench brief. I checked, and it's on Eric's drive. So you guys have this reference if you need it. This is the back side of the PC board. Even though they made a fair number of units, they weren't perfect, and so there's wire wrap wires there to fix the bugs. Okay, now some bad news for at least me so far. This unit was stored in a garage, not outside or anything, but in a garage, and it's got PCB rot, PCB corrosion all over the place. Here's one, here's another picture, and here, and there, and there, and there, and on the back. So I actually showed some of these pictures on the WebEx meetings that we had, and someone gave me the idea of use a fiber pin to scrape gently scrape the corrosion off and try to leave the traces there. I've done that. I've also reseeded all of the ICs. I've also continuity checked all of the traces from start to end, and all the traces side to side, neighboring traces. And it still doesn't work. So there's more work to do with either a multimeter and an oscilloscope, which I don't have, to debug this. But
the chip with the corner missing. All those chips had the corner missing. Oh, on the pictures.
No, not that. No, down a bit, down there. That one at the bottom was that discoloured in the centre at the bottom.
here?
Yeah, what's that going on?
No, I think that's just the picture, but I'll check. Okay. Boom. So I'll close with this picture. This is not entirely a coincidence. This is the HP-75. This is the development unit and the HP-75 pod. They look somewhat similar. Okay. That's it. Any questions? Yeah.
Does your unit have 75C on it, or was the name different first? Was it 75C or A or 75 or 75B or what?
It's a 75C.
You always said 75C.
Yeah.
Okay, thanks.
Not D. D was much later.
Later, but the 71 became the B, so I wondered if the 75 was originally a different letter.
75 has always been C or D.
Okay, thanks. I know it's not a technical question, but
No,
it's a question.
it's a history question, yes.
Chuck, you mentioned that there were similarities in the memory access between the 85 and the 75. Were there more similarities than that?
Oh, yeah. The 75 is basically an 85 in a portable with chips redone. The CPU, the Capricorn CPU that's in the 85 is in the 75. The 75 has a new card reader chip for the pull card. I did the display driver in the 75. There's a chip called the RU chip, which is an all-in-one chip that does the keyboard, some of the display generation. It does the power supply control. There's an MAR chip, memory address register chip, that accesses the SRAM that's in the 75 and also in the expanded module. So the expanded module just has a memory, it doesn't have the address register. So all of that stuff was done custom to integrate it down. So it doesn't support video, it doesn't have the tape drive or the printer support, all that kind of stuff, but the base computing electronics are very similar to the 85. It's heavily leveraged. The idea was, when HP Labs originally did these designs, was just to take that into the 75.
When they did the 85, they knew they were going to make a portable.
When we did the 75, we knew we were going to leverage. And the original design for the 75 was done in HP Labs, and it was redone in Corvallis to take advantage of the new CMOS process that we had. Okay, we're good.